Welcome to today's live stream. Today we're going to be talking about network design. We're going to go through some CompTIA network design questions. We're going to do some review, and we're going to talk about how to approach and tackle these questions when you see them on the exam. So we're going to be using some of the practice assessment questions from CompTIA Learn Lab environment. We're going to show you what these mean and how you can go about tackling these, your strategy behind these questions, and what you need to clue in on. So if you have any questions, please leave a chat or send a message to info@cyberkrafttraining.com or use a chat feature to ask your question. I'll be happy to answer them. So let's go ahead and get started. Again, we're doing implementing secure network designs. We're going to practice this question category. And let's jump right in with one of these questions here. Okay. So evaluate the following choices based on their potential to lead to a network breach. Select the choice that is not a network architecture weakness. Now, when you read these questions, this is how I want you to go about this. Okay. I want you to read the question, read all of the answers, and then reread the question. I don't want you to clue in on a question that you think is correct right away, or stop at a question you think, okay, that must be correct. I want you to think about it and take your time. So we're going to read that. Evaluate the following choices based on their potential to lead to a network breach. Select the choice that is not a network architecture weakness. The network architecture is flat. Services rely on the availability of several different systems. The network relies on a single hardware server. Not all hosts on the network can talk to one another. I'm going to reread the question again. And then you want to think, we're going to make our selection here, okay? You want to take about a minute per question. So take into account the time you've taken on each question. I'm going to make my selection and then answer it. Okay. Now, pay attention to negatives as well. You might see select a choice that is not a network architecture weakness. You might read that as select a choice that is a network architecture weakness. So you want to make sure you pay attention to those negatives, and sometimes there's even double negatives in the question. So if it's not a network weakness, that means it's a strength, right? So sometimes what helps with double negatives is instead of reading the double negative, just make it into something like a positive statement. So if it's not a weakness, it has to be a strength. So which one of these is a strength? Is a flat architecture a strength? No. Services rely on the availability of several different systems. That can create a vulnerability, because if one of those systems, any one of those systems goes down, you'll have a loss of availability. So that increases the risk of a disruption of availability. The network relies on a single hardware server. This one creates a single point of failure. Not all hosts on the network can talk to one another. Well, that's not necessarily a problem there. That's okay. And having not all hosts on the network being able to talk to one another is actually a strength. You want to have your network partitioned into different sections so that if an attacker were to gain access to your network, they don't have access to everything. They don't have the keys to the kingdom. So that's the selection. That's why I chose D. So D is correct. Let's go on to the next one. Again, we're going to for this question, we're going to try and answer this in under a minute. Identify the attack that can launch by running software against the CAM table on the same switch as the target. MAC spoofing, or MAC flooding, MAC spoofing, ARP poisoning attack, and LLMNR. So I'm going to read this again here. So let's go ahead and make a selection. And this is where you're going to get tripped up sometimes with this one. Now we know that this is targeting something on the switch, right? If it's targeting the switch, we're going to be targeting something probably to do with our MAC address, okay? So if we have software running against the CAM table, what does that mean? Well, first off, you have to understand what these types of attacks are, okay? So a MAC flooding attack and a MAC spoofing attack are a little different, but they're very similar. First off, a MAC flooding attack is a type of ARP poisoning attack. ARP is Address Resolution Protocol, and that's what's used with our switches, okay? Now, with a MAC flooding attack, what we're doing is we're putting a lot of different MAC addresses onto the switch. And each of those is going to, the design there is to overload the switch so that the switch no longer functions as a denial of service attack on that switch. MAC spoofing is a way to claim a different identity. So usually this is a way to route network data to a different device on your switch by claiming that you are this device when you're not. So it's not going to be a MAC spoofing attack. And ARP poisoning attack is correct, but it's not the most correct answer. Okay, so we do want to pick A here. And LLMR doesn't have anything really to do with this. This is a Windows-specific resolution service, so that doesn't have any bearing on this. Okay. All right, so let's go on. I hope that helps. And again, I'm not going to answer all of these correct. I want you to see where you might be tripped up, and this is the most common, at least for that question, way in which people switch those up. The other one would be picking that ARP poisoning. Now, if you're selecting these questions and you don't quite get it on the first try, that's okay. You just need to understand your reasoning behind it. All right, analyze the available detection techniques and determine which are useful in identifying a rogue system through software management. We're going to select all that apply. Now, the select all that apply questions are a little difficult because you have to make sure you select every answer that could be right. Visual inspection of ports and switches will prevent rogue devices from accessing the network. Network mapping is an easy way to reveal the use of unauthorized protocols on the network or unusual traffic volume. Intrusion detection and NAC are security suites and appliances that combine automated network scanning with defense and remediation suites to prevent rogue devices from accessing the network. And wireless monitoring can reveal whether there are unauthorized access points. So, again, I'm going to reread the question now that I've read the possible answers. So we're analyzing available detection techniques to determine which are useful in identifying a rogue system through software management. So we want to identify a rogue system, is the key word there. Identify a rogue system through software management. So we know a rogue system is a system or a device that is on the network that's not supposed to be there. It's not known by the security team. We don't really know how it got there. Potentially it's on there by a bad actor, or it could just be some sort of shadow IT where someone within the company has put another device in the network without the IT team's knowledge. So those are our possibilities. Now let's think about these answers. Visual inspection of ports and switches. We're saying visual inspection. It means we're looking at the device. Is that really going to help us? Maybe, maybe not. Network mapping is an easy way to reveal the use of unauthorized protocols in the network. Okay? Creating a network map, mapping out what devices are on our network. Will that help us identify a rogue system? Intrusion detection and NAC are security suites appliances combine automated network scanning with defense remediation suite to prevent rogue devices from accessing the network. Okay? Is that true? Wireless monitoring can reveal whether there are unauthorized access points. So let's go ahead and make a selection here, okay? And we'll talk about why that's correct. Now, this one can be a little confusing. This one trips people up, particularly number C, or question or answer C here. Because this doesn't really tell us that this is a detection technique. Intrusion detection and network access control are security suites and appliances that combine automated network scanning with defense remediation suites to prevent rogue devices from accessing the network. The way that reads, it doesn't really read like that's a detection technique, but that is correct. That's what those devices do, and they do help figure out and determine if there are rogue access points on your network. So that would apply. Now, visual inspection is not going to help. You're not going to be able to tell if there's a rogue access point. Remember, rogue access point is something you're not aware of. So looking at the devices that you're aware of is not going to help. It's not like you're going to go into your server room and there's going to be a box there with That's going to be your rogue access point. That's not how that's going to work. And network mapping is nice, but remember, you don't know about these devices. So when you network map, you're mapping known devices. Now, you can argue that what if you're using network mapping tools to do your network mapping? That could be a technique, and that would help you. But that doesn't say, we're not saying that we're using any automated scanning tools in the network. We're just saying we're using network mapping. So you can't skip ahead in the concept. Network mapping on its own is not going to help you. Using tools like network scanning tools like Nmap, that could help, but it doesn't say that. And then wireless monitoring, this is probably the most straightforward solution. So it's going to be C and D. Charlie Delta. Pretty tough question, trips a lot of people up. That's okay. Now, consider the types of zones within a network's topology and locate the zone considered semi-trusted and requires host to authenticate to join. Private network, extranet, intranet, or anonymous. The way this question reads, the grammar is not super good. Consider the types of zones within the network topology and locate the zone considered semi-trusted and requires, should be like which requires host to authenticate to join. Or requires authentication to join. But anyway, regardless of how the question is written, the key words here, we're looking for a zone that is semi-trusted and requires authentication. So a zone that's semi-trusted and requires authentication. Could that be a private network, an extranet, an intranet, or anonymous? Well, we can say maybe that's an anonymous network. That's not correct, but what we're looking for here is an extranet. Now, extranet is classified as a zone that we provide for maybe business partners, or we provide for contractors, vendors that service our organization, like HVAC vendors, or possibly external IT, physical security consultants, things like that. Or if we're working on a joint venture, we'd have an extranet where we share data, we share systems that we would both companies would use to go after a certain project. So that would be the extranet, okay? This one is considered, I think, a moderate question. And again, we want to spend about a minute per question. So we did okay there. All right, which statement regarding attacks on media access control addresses accurately pairs the method of protection and what type of attack it guards against? Select all that apply. Now again, select all that apply can be pretty difficult. MAC filtering guards against MAC snooping. Dynamic host configuration protocol snooping guards against MAC spoofing. MAC filtering guards against MAC spoofing. And DAI guards against invalid MAC addresses. So what would apply here? So you're going to need to understand, first off, what MAC filtering is, what MAC snooping and what MAC spoofing is, DHCP, and DAI. So let's go ahead and make our selections here. Now, this one, again, is pretty tricky. You want to think about, first off, if you don't know what DAI is, you're going to have to take a stab at that, okay? That's going to be dynamic ARP inspection. And that allows you to inspect address resolution protocol to determine if there's any sort of attacks against it. So it's not saying what type of attack we have. So which statement regarding attacks on media access control addresses pairs the method of protection with the attack it guards against. So that's the key. So what we have here is DAI guards against invalid MAC addresses. So if we're trying to spoof a MAC address, DAI should help detect that. So that's, if you know DAI, you should know that that's one of the things it does. That's going to help. Dynamic host configuration protocol snooping guards against MAC spoofing. Okay, so if we have a DHCP server, we're going to be able to detect if there's any MAC spoofing where a device is trying to claim that it's a different device on the network. So that's correct. Now, MAC filtering guards against MAC spoofing. MAC filtering is whenever we allow connections only to certain MAC addresses, but that does nothing to prevent devices from changing their MAC address, so from spoofing them. So that's not good. And MAC filtering guards against MAC snooping. Again, the same thing. MAC filtering allows connections to and from only certain MAC addresses. That doesn't do anything to prevent people from sniffing or snooping or determining what MAC addresses are used on the network. So if you understand MAC filtering, you should be able to eliminate these two. Select all that apply. Most of the time, that's going to be multiple answers. So if you're able to eliminate these two, and you don't know what DAI is or what DHCP snooping is, just go ahead and take a stab and select both of those. As long as you're able to eliminate two of them, selecting two of them on a select multiple questions, that's usually the right call. It's not always, but usually you want to select more than one answer. So that's a technique that might help you there. Okay, where should an administrator place an internet-facing host on the network? DMZ, bastion host, extranet, or private network. Now, some people get tripped up on this by seeing bastion host, and they might think, oh, I'll place it on the bastion host. But again, it's asking you where you would place a host on the network. You're not going to place a bastion host on a bastion host. So the correct answer here, we're going to select demilitarized zone. Okay. Now, bastion hosts, they do reside in the DMZ. Okay, but we're not going to place a host on a host. Now, so DMZ is going to be the correct answer there. Extranet, that's semi-trusted. That's not really internet facing. And a private network, that's not where we're going to place our internet facing devices. So pretty straightforward on this one answer. And if you're on the easier questions, if you're averaging under a minute, you're doing a good job, because then you can spend a little more time on the more difficult questions. Evaluate the typical weaknesses found in network architecture and determine which statement best aligns with a perimeter security weakness. All right. So let's read the answers here. A company has a single network channel. A company has many different systems to operate one service. A company has a habit of implementing quick fixes, and a company has a flat network architecture. Okay, so what we want to cue in on some keywords here. Evaluate typical weaknesses found in network architecture. So that means these are going to be weaknesses, probably, and determine which statement best aligns with a perimeter security weakness. Okay, perimeter security weakness. Now, we have to, first off, if these are not weaknesses, we can discount them. So if they're strengths, that's not a problem. Company has many different systems to operate one service. Company has a habit of implementing quick fixes. Company has a flat network architecture. Let's go ahead and make a selection. And here's what we get. Okay. Now you want to think about this as how each of these relate to one another. So a company has a flat network architecture. That's the correct answer. Let's read into each of these. Overdependence on perimeter security occurs when a network architecture is flat. If an attacker can penetrate the network edge, the attacker will have freedom of movement through the entire network. Okay, so that means if we don't have those different security segregations within our network, if we have a flat architecture, one breach can access pretty much everything. A single point of failure occurs when a pinch point by relying on a single hardware server or appliance or network channel. Complex dependencies are services that require many different systems to be available. So we'll have a complex dependency if we have many different systems operating one service. And let's see, single network channel, that's fine. A flat network architecture. Now this is going to be, the reason why this is the correct answer is because this one is going to be a weakness on the perimeter. So if we have a perimeter breach, that's going to have the greatest impact, the highest risk at impacting our network. Quick fixes, they're obviously not ideal. You don't want to have quick fixes or knee-jerk reactions as part of your security plan, but does that really necessarily address a perimeter weakness? Remember, perimeter would be the key word here. No, it doesn't. Okay. Now, again, if you're working through these and you get some questions wrong, that's perfectly fine. That's why I'm answering this way. I'm not going to try and answer all these 100% correct. Make you, I want to give you some confidence. It's okay to make mistakes, especially when you're practicing the questions. The idea here is you're training your brain to think about these questions in a certain way. An ISP customer's network is under a distributed denial of service attack. The ISP decides to use a black hole as a remedy. How does the ISP justify their decision? So let's think about that. A black hole. First off, this is basically a straight vocabulary question. You need to know what a black hole is. Okay? So let's read these different possible responses. Let's go ahead and make a solution. Now, if you didn't know what a black hole was, the key is in the name. What does a black hole do? It sucks everything in. Nothing can escape from a black hole, not even light. So I know a lot of cybersecurity terms aren't necessarily named correctly, but a black hole is. And that's what a black hole does. It drops packets for affected IP addresses into a separate area of the network, does not reach any other portion of the network. So that separate area is basically your black hole. It sucks all the packets in, nothing gets out. Okay? So if you're under a distributed denial of service attack, basically you're routing all the packets to this portion of the network where they can't escape. So they're not going to bring down, they're not going to disrupt the availability of your different systems. Now, some of these keywords that are going to discount these answers, the black hole will not continue to send packets anywhere else. So if we have any of these choices telling us that it's going to send packets somewhere else, that's not going to do. That's not going to be correct. Black hole routes traffic destined to the affected IP address to a different network. That's not correct because we're sending the packets somewhere else. A black hole is preferred as it evaluates each packet in a multi-gigabit stream against an access control list without overwhelming the processing resource. This is not really what a black hole is. So it's a good red herring. It's a good false question, and it trips up a lot of people, but that's not a good definition of black hole. So the first one would be correct. Okay. Okay, again, we have another difficult question here. Compare the characteristics of a rogue access point in wireless networks to determine which statements correctly summarize their attributes. So keywords in the question. We're going to read all of these. Compare basically which statements correctly summarize a rogue access point. So which of these are correct when we talk about a rogue access point? An evil twin is a rogue access point. An attacker can use denial of service to disconnect users from the legitimate AP and connect to the evil twin. Okay? Sometimes referred to as an evil twin, a rogue access point masquerading as a legitimate access point may have a similar name to the legitimate access point. An attacker can set up a rogue access point with something as simple as a smartphone with tethering capabilities. An denial of service attack will bypass authentication security enabled on the access point, so it's important to regularly scan for rogue access points on the network. So which of these is correct? So is an evil twin a rogue access point? And can attackers use denial of service to disconnect users from the legitimate access point to connect to the evil twin? That describes a disassociation attack, which is correct. Sometimes referred to as evil twin, a rogue access point masquerading as legitimate AP may have a similar name. That is the definition of an evil twin. An attacker can set up a rogue access point with something as simple as a smartphone with tethering capabilities. Now, it doesn't have to say simple here. A smartphone with tethering capabilities acts as a router. So a router can do a rogue access point. You need a router for a rogue access point. So we're going to select those three, and that's correct. Okay? So you want to think about how each of these statements is true. The last statement there, denial of service attack will bypass authentication security enabled on the access point, so it's important to regularly scan for rogue APs on the network. Now, denial of service attack is an attack on availability. doesn't have anything to do with authentication. So saying that it bypasses authentication is not really correct. So right there, that should kind of spark something in your brain, make you think, okay, well, we're talking about availability here and we're talking about confidentiality here. So that's probably not correct. It's important to regularly scan for rogue access points in the network. This second part is correct, but the first part doesn't make sense. So that answer would be false. Okay. All right, given knowledge of load balancing and clustering techniques, which configuration provides both fault tolerance and consistent performance for application like streaming audio and video services? So keywords here. Given knowledge of load balancing and clustering, so we're talking about load balancing and clustering, what provides fault tolerance and consistent performance for streaming? So fault tolerance and consistent performance. First in, first out clustering, fault tolerant clustering, active clustering, active passive clustering. Okay, so we need to provide two different things, okay? Fault tolerance and consistent performance. So let's go ahead and take a selection. And this is what we're going to get. Active and passive clustering means if we have an active node and the active node fails, the passive node is going to automatically take over. So that would provide both fault tolerance and consistent performance. Okay. Now, active is a little different. This basically it works by having two nodes active at the same time. So they both process the service, the streaming service, simultaneously. If one of those nodes goes down, though, everything goes to the other active node, which does provide load balancing, but you're going to have a decrease in performance because you're only working with half your processing power. So that's why that one's not going to be correct. First in, first out clustering. This is just a method of configuring your load balancing. Doesn't really address what we're talking about. And fault tolerant clustering doesn't, again, properly address what we're talking about here. Okay, there are several types of security zones on network. Analyze network activities to determine which of the following does not represent a security zone. DMZ, screened host, wireless, or guest network, which would not be a security zone. Now, one of these should stick out at you if you know your vocabulary. Now, if you don't know your vocabulary, that's okay. We can kind of guess at this a little bit. Demilitarized zone has zone in the name. That should be an obvious one. So that's probably going to be correct. Again, this is a single choice. What does not represent a security zone? A guest network and a wireless network. So those constitute their own zones. You have to think about that, and you have to understand what is a screened host. Now, if you don't know what a screened host is, you could have some trouble here. We're going to go ahead and make a selection. So a screened host is a smaller portion of your network that will access the internet through either a proxy or a gateway. Okay, so understanding what a screened host is going to get you this question right away. Even if you don't know that, you should understand that a wireless and a guest network, those are zones. Those are zones we could select. So if you didn't know what a screened host is, you could still puzzle this one out. But again, this is one of those straight vocabulary questions. We have a mix of those and the harder questions on here. Okay, attacker tricks a host within a subnet into routing an attacker's machine through an attacker's machine rather than the legitimate default gateway, allowing the attacker to eavesdrop on communications and perform a man-in-the-middle attack. Compare the types of routing vulnerabilities and conclude what the attacker is exploiting in this scenario. So the keywords we want to clue in on. This just sets up the scenario. Tricks a host within a subject, routing through an attacker's machine rather than a legitimate default gateway. We're performing a man-in-the-middle attack. We're comparing routing vulnerabilities to conclude what the attacker is exploiting in this scenario. So which routing vulnerability would be used here? Would we use route injection, denial of service, ARP poisoning, or source routing? So let's think about that. We're tricking a host within a subnet. So let's go ahead and make a selection. Anybody have any ideas? Okay. Go ahead and make a selection here. And this is a classic example of ARP poisoning. Okay? ARP poisoning, the basic definition is that we're tricking a host on a subnet to route through the attacker's machine rather than a legitimate gateway. So that's basically a one-to-one definition of ARP poisoning. Okay. All right, so again, let's go to this next question, and then we're going to wrap up the session for today. Partly because my camera stopped working. All right, so which statement best describes the difference between session affinity and session persistence? We have to read each of these, and this is one of those questions, when you see a lot of text like this, you have to read it very carefully. This is one of those questions you want to spend a little more time on, okay? You want to make sure you have that time available to you to practice and work through questions like this, because these can be the most difficult questions that you're going to encounter. All right, so with persistence, once a client device establishes a connection, it remains with the node that first accepted its request, while an application layer load balancer uses session affinity to keep a client connected by setting up a cookie. Session affinity makes node scheduling decisions based on health checks, processes incoming requests based on each node's load. Session persistent makes scheduling decisions on a first in, first out basis, or FIFO basis. With session affinity, when a client establishes a session, it remains with the node that first accepted its request, while an application layer load balancer uses persistence to keep a client connected by setting up a cookie. Session persistence makes scheduling decisions based on traffic priority and bandwidth considerations, while session affinity makes scheduling decisions based on which node is available next. Okay, so we want to clue on some keywords here: affinity and persistence. Now, what could these mean here? So if we want to establish a persistence in a session, we're going to need some sort of device. Okay? So what technology can help us with that? So let's think about that when we read these. Okay. Uses session affinity to keep a client connected by setting up a cookie. Okay, so a cookie could be used to establish persistence. Okay, but this one says we use session affinity to keep a client connected with a cookie. So affinity would not really relate. We want to relate persistence to that cookie. Session affinity makes node scheduling decisions, and then session persistence makes scheduling decisions on a first in, first out basis. Is that really what we're looking for here? Let's keep looking. We want to focus on that cookie, the use of the cookie. Application layer load balancer uses persistence to keep a client connected by setting up a cookie. Okay, that's what we're looking for here. And let's see. Session persistence makes scheduling decisions based on traffic priority. So persistence is not going to have anything to do with priority. So we want to think of this one seems the most correct. Now let's read this one in relations to affinity. With session affinity, when a client establishes a session, it remains with the node that first accepted its request, while an application layer load balancer uses persistence. Okay, so that kind of makes sense. So let's go ahead and try that one. And that's correct. So we were able to puzzle that one out by establishing what persistence is, and persistence would be established with that cookie. Now this one also mentions cookies, but this one mentions cookies in relations to affinity, which is not what we're looking for. So this one is definitely going to be that third one there, where we establish persistence. Now, apologize about my camera. I keep turning it on, see if it's going to be working again. But I do hope this was helpful for you. If you have any questions, please leave a comment or a chat. I'd be happy to answer them. And thanks so much for joining in. Have a wonderful evening. Take care. And if you're interested in Security Plus training, to get your Security Plus certification, we have links in the description below. We can help you. Cyberkraft, we offer cybersecurity training. We're a CompTIA authorized partner. We'll give you full access to this Learn Lab environment when you sign up for one of our courses. And we have instructor and self-paced based learning available for you. So please check out the links in the description. Hope you have a wonderful day. Thanks so much. Have a great day.